Welcome back to week 6 of online learning geometry at home. It's Mr. Natsky again coming from his basement for another video for you. A couple announcements to get the week started. You should have received everything. Remember, everything can be found on Schoology. You should have received an email through Schoology. It's got the week 6 Google Doc, which you can open up. It's got our weekly message, and then our weekly plan for the week. Today, in task number 1, the video here, we're going to talk about a little quiz review. And you got some practice problems, and then you're going to take a quiz on solving triangles. And we have task 2 coming up later in the week, which we'll talk about circles. You can got the Google Doc. You can use the links are all there. Obviously, I haven't uploaded the videos yet, so I don't have links to those, but they'll be there as well. Everything's also found here in Schoology in the week 6 document. So if you can, go ahead, print out the quiz review. It's got the practice problems on for you. If you can't, you can just write the practice problems down, scratch a piece of paper, notebook, blank piece of paper, and go from there. I will start out the video with a review of the formulas and a review of which ones to use, and then it'll be followed by some examples. My recommendation for you is go ahead and listen to the review here and the formulas. Then I want you to try the practice problems, the examples on your own, and you can check them. So if you got the blank quiz review, so no, there it is. You can print it out. There is the answer key right here. It's the answer key. And there's worked out solutions for the entire quiz review. You can check your answers, and if you totally understand them, you don't need to watch the second half of the video at all. There are some resources. There's a flow chart, and this is probably the first part of the video I'll talk about. We've talked about this the last couple of weeks. This flow chart here is telling us how do I know how I'm going to solve the triangle? What am I using? We got the quiz review formulas. These are all the formulas that we'll use. SOHCAHTOA, and then summary on when I'm using SOHCAHTOA, what questions to ask yourself. Law of sines and law of cosines. Now you did have these in your notes from the previous weeks, but here they're all combined into one file. And then once you've completed the review and you're ready, you need to complete the quiz. The quiz is found in the Schoology Independent Practice and Quiz folder. It's week 6, task number 1. Make sure when you click on to start the quiz, do make sure you read the directions before you start, because once you start the quiz, you will not be able to leave and come back. You'll need to finish it all at once. Do not round until your final answer. Make sure you round all answers to the nearest 100, 2 decimal places. Have your calculator ready. Make sure the mode is in degrees, and if you want to use the formula sheets, have them ready to go or have them jotted down. So as a reminder, we're putting our calculator in degrees. To check it, we go to our mode, scroll down, you see where my mouse is, see the word degrees here. My degrees is highlighted, I am in degrees, so I've checked it, I'm in. If not, otherwise you scroll down to it, scroll over to where degrees is, and just hit enter, and it will select it. And you can quit to get out of there. Let's review so that's kind of summary of what we are. Remember, on Schoology 2, grading's there, office hours, here's the hours. Stop in and check. And if you have any questions before you start the quiz, stop in and see your teacher on Monday. Talk with them. They can help answer any questions, or even Tuesday, it doesn't matter when it is, before you start the quiz, so that you can get those answered and taken care of to prepare yourself. Do remember, on the quizzes, the accuracy does count, and the quizzes will count for 30% of your overall grade. So the first part of our quiz review is just to review the formulas. Reminder, if you got any questions on last week's independent practice, stop in office hours, check it out. We're looking at modules 13 here. We're going to talk about SOHCAHTOA and the Pythagorean theorem, and module 14, which dealt with law of sines and law of cosines. Here we've got our flow chart. Remember, this is asking, these are the questions to ask for, what am I going to use to solve this triangle? The question is it a right triangle? That's the first question we have to ask ourselves. If our answer is yes, you have the Pythagorean theorem or SOHCAHTOA. Pythagorean theorem is a squared plus b squared equals c squared. We're going to use that if I know two sides of a triangle and I want to find the third side. That would be our first option. SOHCAHTOA we will use if I know two sides and I want to find an angle, or if I know an angle on one side and I want to find the second side. So means represents sine, which is the ratio of opposite over hypotenuse. Ka represents cosine, which equals the ratio of adjacent over hypotenuse, and toa represents tangent, which equals the ratio of opposite over adjacent. Well, if it's not a right triangle, then we've got our two laws we came up with. So the question we ask ourselves there is there an opposite angle side pair that I know the measure of both of them for? If my answer is yes, I'm going to use the law of sines. And remember, law of sines is the ratios, okay, of the side over side of an angle, or sine of an angle over this side. And we only use two out of those three. If there is not an opposite pair, then I'm going to use law of cosines. We'll talk a bit more about that. So remember, SOHCAHTOA, we always, whatever I'm talking about, so in this case, if I say sine of A, angle A is my reference angle. The hypotenuse is always across from the right angle. The adjacent represents the leg that is next to my reference angle. Opposite represents the leg that is across from my angle. Cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. And as I work through this to determine which one I should use, here's our summary to do it. Draw and label a picture. If it's not given to you, draw it out. Check to see if you can use the Pythagorean theorem. That's the first thing we should ask ourselves. And we can do that if I know two sides and want to find the third side. Well, if that's not the case, then the questions I ask myself, what's my reference angle? Based off of that, what sides am I working with? Well, ask yourself, what side do you know? And what side do you want to know? Are those sides opposite, adjacent, or hypotenuse? That will then tell me which trig ratio should I use, sine, cosine, or tangent, based off of those. Set up our equation and solve it. Remember, we're going to solve. If we're solving for a side, we're going to end up clearing fractions to solve. If I'm solving for an angle, I'm going to end up using the inverse. And then when you're done, check your final answer. Does it make sense? Law of sines, I've got the two. Remember, there are three ratios. When we solve using law of sines, we only use two of them. We either do sine of the angle over the sides, and whatever we're solving for, we're going to put that one on top. So we use that one if we're solving for an angle. Or we put A over sine of A, B over sine of B, C over sine of C. These sides, which represent the lowercase letters, on the top, and sine of the angles on the bottom if we're solving for a side. Now we're only going to use two of those. And when do I use law of sines? Again, we have to have an opposite pair that I know the measure of. Because when I set up law of sines and I set up my proportion, I should only have one missing variable in my proportion. If I have two, I either set it up incorrectly or I'm not able to use law of sines to solve that. And if there isn't an opposite pair, we got law of cosines. And here's our formulas. Okay. A squared equals b squared plus c squared minus 2bc times cosine of a. Remember, lowercase letters represent sides. The uppercase letters represent angles. So I will use law of cosines to find the missing side of a triangle if I know the other two sides and the included angle. That means the angle between those two sides. So if I know sides A and C, I would have to know angle B in order to use law of cosines to solve for side B. I can also use it to find the missing angle of a triangle. In order to do that, I must be given a measure of all three sides. And if I'm asked to find one specific angle, just use whichever one it is to find that. This is just a extension note. If you're ever asked to solve for all the angles, or you have to solve or find all of them, always find the largest angle first. So that's my review for it. So what I would recommend, the next part we got here is our quiz review, is the practice problems, the example problems. So my recommendation for you, if you've watched this, is go ahead, pause the video, and I want you to try all of the examples on your own. So you can either print it out or just use the blank one to look at and use as reference to jot down on a piece of paper. Try them on your own and check to see how you're doing. Again, the links are in Schoology. So you've got your quiz review. It's our blank one. Here's the answer key. You can check your answers. They're also in the Google Doc. If you click on the links, the quiz review, try to complete on your own, check your work in the provided answer key, and there it is. So we're going to solve for either an indicated side or angle. Try it on your own. If you tried it and you got it wrong and you still can't figure it out, go to YouTube, check out the video. And there's links at the bottom of the YouTube videos to take you directly to specific examples that are in there. Just click on the time and it will take you right to that specific example to check it. So you don't have to watch the entire video to check on if you just have a question on one or two examples. And again, too, if you have questions, stop in during office hours. So at this point now, I'm going to go on and just talk you through each of the example problems. So as you come on in. So as we do the examples, the one thing we're going to do every single time is ask yourself first, what am I using? Example number 1. So the first question is it a right triangle? Yes, it is. I'm either using Pythagorean theorem or SOHCAHTOA. Well, I know two sides, and they want me to find the measure of side A. So I know 2, I want to find a third side. I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared. Remember, C represents the hypotenuse. And in this case, side A happens to be the hypotenuse. So I will do 7 squared plus 15 squared equals A squared. Square both those terms, I get 49 plus 225. I add them together to get 274. How do I solve for A? Yeah, take the square root. The opposite operation of squaring a number is take the square root. Square root of 274 is 16.552. Round that to the nearest hundredth. 2 decimal places, I get 16.55. Example number 2. I'm going to find the measure of side B. Well, what am I going to do? Is it a right triangle? Yes. Pythagorean theorem or SOHCAHTOA. I know two sides, and I want to find the third. Pythagorean theorem. A squared plus B squared equals C squared. Note, B, the side I want to find, is one of the legs. So C is going to be 17. I'll let 11 be A, so I get 11 squared plus B squared equals 17 squared. Square those numbers, 11 squared and 17 squared, I get 121 plus B squared equals 289. I'm solving for B squared, so let's get that by itself. So I'm going to subtract 121 from both sides. I have B squared equals 168. How do I undo that and get B by itself? Yeah, we're going to take the square root of both sides. Square root of 168 is 12.961. Rounded to the nearest hundredth is 12.96. Example number 3. Is it a right triangle? Yes. Can I use Pythagorean theorem? No, because I only know one side, so I'm going to have to use SOHCAHTOA. And one of the questions I ask myself when I use SOHCAHTOA, what's my reference angle? Well, the reference angle is the angle I know the measure of. That means 28 is my reference angle. Which side do I want to find? I want to solve for C. Which side do I know? 27. Well, as I look at this, 27 is across from the right angle, so that's my hypotenuse. C is the leg that is next to my reference angle, that is adjacent. The side I don't have anything with, that is my opposite side. So C is adjacent, 27 is hypotenuse. Which trig function uses adjacent hypotenuse? Yes, cosine does. So I'm going to set it up. Cosine of the angle. Cosine of 28 equals the ratio of adjacent over hypotenuse, C over 27. Solving for a side, let's get BC by itself. So let's clear fractions. Clearing fractions, I need to multiply both sides by 27. They'll cancel on the right. I have 27 times cosine of 28. Type that into my calculator. 27 times cosine 28. I end up with 23.839, which rounded to the nearest hundredth is 23.84. Example number 4 says find the measure of C. Is it a right triangle? Yes. How many sides do I know? Only one. I'm using SOHCAHTOA. What's my reference angle? Which angle do I know the measure of? 27. Which side do I want to know? C. Which side do I know the measure of? 16. Well, the side across from the right angle is the hypotenuse. Which is the side I don't need. 16 is the leg that's next to the reference angle, so that's my adjacent leg. C is the leg that is across from 27, that's my opposite. So C is opposite, 16 is adjacent. Which trig function uses opposite and adjacent? Tangent. Tangent of 27 equals C over 16, opposite over adjacent. How do I solve? Well, let's clear fractions. To clear fractions, I need to multiply both sides, but I got to get rid of this denominator of 16. So I'm going to multiply both sides by 16. They'll cancel out on the right, leaves me with just C. I have 16 times tangent of 27. 16 times tangent 27, type it into my calculator. And I get 8.152. Rounded to the nearest hundredth is 8.15. Example number 5. Is it a right triangle? Yes. So I know two sides, looking for a third? No. So I'm going to use SOHCAHTOA. What's my reference angle? Which angle do I know the measure of? 62 degrees. Which side do I want to know the measure of? In this case, let's find the measure of side C. It's labeled in my picture. So I want to find C. Which side do I know the measure of? 7. Well, which ones are they? C is across from the right angle, so that's my hypotenuse. 7 is the leg that is across from the reference angle of 62, so that's opposite. The side I don't know, that would be my adjacent. So the side I want to know is that hypotenuse. The side I know the measure of is my opposite side. Which trig ratio uses opposite and hypotenuse? Sine. So sine of 62 equals the ratio of 7 over c, because it's the ratio of the opposite side over the hypotenuse. I need to start by clearing fractions. I'm going to multiply by the denominator, which is c. That will cancel out the c's on the left. I have cleared fractions. And I have c times sine of 62 equals 7. So I've gotten rid of fractions. I'm going to get c by itself. Remember, sine of 62 is a number. Well, if I had a number times c, I would divide by that number to get c by itself. So I'm going to divide both sides by sine of 62. So c will equal 7 divided by sine of 62. 7 divided by sine 62 equals 7.927. Rounded to the nearest hundredth. 7 tells me to round up, so it's 7.93 is my answer. Example number 6. Is it a right triangle? Yes. Do I know two sides and want to find the third? No. So I'm going to end up using SOHCAHTOA. So what's the question? What's my reference angle? Which angle do I know the measure of? 50 degrees. That's my reference angle. Which side do I want to know? I want to know B, and I know the measure of the 12. Well, how do those relate to my reference angle? Side B is across from the right angle. That's my hypotenuse. 12 is the leg that is next to my reference angle of 50, so that is adjacent. AB, the side I have nothing to do with, is the opposite. So I want to find the measure of the hypotenuse. I know the measure of the adjacent. Which trig function uses adjacent and hypotenuse? Yes, cosine does. The cosine of the angle, cosine of 50, equals the ratio of adjacent over hypotenuse, which is 12 over b. Solving, I need to clear fractions. Multiply both sides by b. The b's will cancel on the right. I have b times sine of 50 equals 12. I have gotten rid of fractions. I want to solve for b. I got to get b by itself. Since I am multiplying that by cosine of 50, the opposite operation is to divide both sides by cosine of 50. They'll cancel out, and the right leaves me with just b. b will equal 12 divided by cosine of 50. 12 divided by cosine of 50 equals 18.668. The third number, which is 8, tells me to round up, so it's 18.67 is my answer. Example number 7. I want to find the measure of angle C. Is it a right triangle? Yes. Can I use the Pythagorean theorem? No. Because the Pythagorean theorem is only used if I'm trying to find a side measure. Since I'm trying to find an angle, I have to go to SOHCAHTOA. So what's my reference angle? Well, the reference angle here is the angle I want to find the measure of. I want to find the measure of angle C. So C is my reference angle. Which side do I want to know the measure of? Well, I don't. So we're going to ignore that question. Which side do I know the measure of? Well, I know two of them. I know 26 and 44. How do they relate to C? So if C is my reference angle, .44 is across from the right angle, so that's my hypotenuse. 26 is the leg that is across from C, so that's the opposite. I got nothing to do with the adjacent. So what do I have? Opposite and hypotenuse. 26 is opposite. 44 is the hypotenuse. Which trig function am I going to use? Sine. So as I said on my equation, sine of C, sine of the angle, will equal the ratio of opposite over hypotenuse, which is 26 over 44. What is the opposite operation? How do I get rid of sine? If I want to cancel it out, remember the opposite operation of sine is to do the inverse. If I take sine inverse of sine, they will cancel each other out, and it leaves me with just C on the left side. So C then equals sine inverse of 26 over 44. So into my calculator, how do I get to sine inverse? Remember, it's the sine button, but I have to hit second first. So second sine is sine to the -1. That's sine inverse. Sine inverse of the ratio of 26 divided by 44. And I get 36.221 rounded to the nearest hundredth. The 1 tells me to round down, so it stays at 36.22 degrees. Example number 8. Is it a right triangle? Yes. I'm either using Pythagorean theorem or SOHCAHTOA. But they asked me to find the measure of angle A. So Pythagorean theorem is out the window. Because I don't use that to find angles, I have to use SOHCAHTOA. So let's ask ourselves our questions. What's the reference angle? I don't know the measure of any of the angles, but which angle do I want to find the measure of? Yeah, angle A. That's my reference angle. Right there, it's my reference angle. Which sides do I want to know the measure of? None, so forget it. Which sides do I know the measure of? Because if I'm trying to find an angle, I will need two sides. I know the measure of 26 and 10. Well, how do those relate to it? Well, the side I don't know, that's the hypotenuse because it's crossing the right angle. So 10 and 26 are both legs. Well, 10 is the leg that is next to angle A, so that's my adjacent leg. 26 here is across from angle A, so that's my opposite leg. So 26 is opposite, 10 is adjacent. Which trig function uses opposite and adjacent? Yeah, tangent. So tangent of my angle, tangent of angle A, equals the ratio of opposite over adjacent. That is 26 over 10. How do I undo tangent? How do I get rid of it? I'm going to take the inverse. Tangent inverse of tangent will cancel that out. We'll get rid of tangent and leave me with just A on the left side. So A equals, I'm taking tangent inverse of the ratio of 26 over 10. Second tangent is tangent to the -1. That's tangent inverse of 26 divided by 10. And that equals 68.962, which rounded to the nearest hundredth is 68.96 degrees. Example number 9. Example number 9. Do I have a right triangle? No. Do I have an opposite pair? Well, I want to find side B. Well, side B and angle 14 form an opposite pair. But I need an opposite pair. I know the measure of 135 and no. 10 and no. However, I am given 2 out of the 3 angles, which means the 3 angles of a triangle add up to 180 degrees. That means angle A is actually 31 degrees. 180 minus 35 minus 14 gives me angle A to be 31 degrees. So I do have an opposite pair here that I know the measures of both, angle A and side A. So yes, I can use law of sines. I'm solving for a side. So therefore, I am going to put the sides on top. I'm writing my ratios. B over sine of 14 equals the ratio of my other opposite pair, which is 10 over sine of 31. Notice I put B and 10 represent sides, and in the bottom I have sine of the angles, and each ratio represents an opposite pair. How do I solve for B? I got to get B by itself, so I'm dividing it by sine of 14, so the opposite operation of that is to multiply both sides by sine of 14. They will cancel on the right. So B will equal 10 divided by sine of 31 times sine of 14. Type this into my calculator. 10 divided by sine of 31. Make sure you close the parentheses after the 31 before you multiply that by sine of 14. And I end up with 4.697. Remember, don't round to our final answer, which rounds to 4.70 or 4.7 miles. Example number 10. Do I have a right triangle? No. 29 plus 53, angle A is not 90 degrees. Ends up being 82. So angle A is about 98 degrees. So no, it's not a right triangle. Do I have an opposite pair? 29 and 4.9 are an opposite pair, aren't they? But I know the measures of both. So yeah, I'm going to do law of sines. So 4.9 and 29 are opposite pair, and B and 53 are an opposite pair. Solving for sides, so I'm going to put the ratio. B over sine of 53. 53 degree angle is opposite of side B, equals the ratio of 4.9 over sine of 29. How do I solve? Get B by itself. I'm going to multiply both sides by sine of 53. They'll cancel on the right. Leaves me just B. B then equals 4.9 divided by sine of 29 degrees times sine of 53. 4.9 divided by sine of 29. Make sure you close the parentheses. Times sine of 53. And end up with 8.071. The 1 tells me to round down, so it's 8.07 miles is my answer. Example number 11. Do I have a right triangle? One angle 70, and no, I do not. So I'm either using law of sines or law of cosines. Do I have an opposite pair? Well, 8 and 70 are opposite, so there's an opposite pair. And again, I want to solve for angle C. Well, that forms an opposite pair here with 5, so I'm going to use law of sines. So now that I'm solving for the angle, I want to put the angle on top. So I'm going to put sine of C on top over 5. So I'm putting the sine of the angles over the sides equals, that's one opposite pair, another opposite pair, which is sine of 70 over 8. I'm going to get C by itself. Well, first we got to get sine of c by itself. So let's get rid of the 5. Let's clear fractions on the left side. So I'm going to multiply both sides by 5. They'll cancel out. And that gives me sine of c equals sine of 70 over 8 times 5. Sorry, I got a little head in the quickens here. It wasn't working like I wanted to. But how do I get rid of sine? Like we talked about earlier. I want to do the inverse. Take the inverse. The inverse of sine of c will cancel it out. And I'm left with, so that gives me just c. C equals then sine inverse of sine of 70 divided by 8 times 5. So we type that into our calculator. We can type it all in at once. So I'm going to do sine inverse of sine of 70. Make sure you close the parentheses after the 70. Divided by 8 times 5. And I end up with 35.966. Another option here, which you can do, and some of you have done, but do make sure you don't round, is I can determine what that right side is. I can take sine of 70, divide that by 8, and multiply that by 5, right? So the right side is actually equal to 0.5873. That's what I'm going to take sine inverse of. So I can do sine inverse of that number, but remember, if you're going to do that, do not round before a final answer. So we're going to use the answer feature in our calculator, which is the second negative, because if you're rounding before your final answer, your answers are going to be off a little bit. And I know, as I've seen some of the homework, some of you have been doing that, and your answers have been off. I get 35.966 here. So for example, if I would have did sine inverse of 0.59, round 2 decimal places, I get 36.15. I'm off, ain't I? Not a whole lot, but it's enough to be off. So make sure we don't round to our final answer. This second 6 tells me to round up. Angle C is a measure of 35.97 degrees. Number 12, find the measure of angle C. Right triangle? No. Do I have an opposite pair? Well, 6 and 53 are an opposite pair. And 4 is an opposite pair with C, which is the angle I want to find. So yeah, I've got an opposite pair. I know the measure of both. Another. So I'm going to use the law of sines. And I'm going to put the angles on top because I'm solving for an angle. So sine of C over 4, because that's the side that's opposite of angle C, equals my other angle, which is sine of 53 over 6, because that's the side that's opposite of it. So sine of C over 4 equals sine of 53 over 6. Let's clear fractions. Multiply both sides by 4. We'll cancel out. On the left side, I get sine of C equals sine of C equals the ratio of sine of 53 divided by 6 times 4. How do I solve for C? Take the inverse. If I take the inverse, sine inverse is sine, they'll cancel each other out, leaves me with just C. C equals sine inverse of sine of 53 over 6 times 4. So by typing it in once, so second sine is sine inverse. Sine inverse of sine of 53 make sure I close the parentheses for the 53, divided by 6 times 4, I get 32.169. Again, remember we don't want to round to our final answer, so I can determine the right side if I want to, which is sine of 53, right? Okay, equals 0.798. Let's divide that by 6. So I'm going to do answer divided by 6, right? Then multiply that by 4. And then take sine inverse of 0.53. Now I don't want to round it, so I'm going to use the second negative, which is the answer feature, to get, again, 32.169. Again, just to point out, if you do sine inverse and you round the number 0.53 instead of the entire number, I'd get 32.00. I'm off. Off a little bit. Not much, but I'm still off, so it's not 100% accurate. So I get 32.169. The 9 tells me to round up, so it's 32.17 degrees is my answer. Example number 13. Is it a right triangle? No. Do I have an opposite pair? Well, I want to solve for side B. So B and 75 do. So there's one, but I need another opposite pair. A and 14, no. C, no, I do not have an opposite pair. Therefore, I need to use the law of cosines. I'm going to use the law of cosines I'm going to use. Since I'm solving for side B, I'm going to use the one where B squared equals A squared plus C squared minus 2AC times cosine of B. A is 14. C is going to be 15.5 because it's opposite of angle C. So B squared equals 14 squared plus 15.5 squared minus 2 times 14 times 15.5 times cosine of 75. The nice thing with the law of cosines is I can type that all into my calculator at once. 14 squared plus 15.5 squared. I'm going to start over because I forgot the plus. I have 14 squared plus 15.5 squared minus 2 times 14 times 15.5 times cosine of the angle, which is 75 degrees. And I get 323.922. That's not my answer. That's what B squared equals. How do I solve for B? Yeah, I need to take the square root of that. And again, I don't want to round to the final, so I'm going to do, when I do the square root, I want the entire number typed in there. Well, I do that by doing second negative, which is the answer feature, so it'll take the entire decimal. And I get 17.997, which rounded to the nearest hundredth, 2 decimals. So my third number, the 7, tells me to round up. Well, if I round 9 up, it becomes a 0. The 9 becomes 0. I end up with 18 inches as my final answer. Example number 14. Find the measure of side C. Do I have an opposite pair? Well, C and 150 is, but do I have another one? No. Law of cosines. Solving for side C, I'm going to use C squared equals A squared plus B squared minus 2AB times cosine of C. A, I'm going to use 15 because it's the side across from angle A. I'm going to use 8 for B because it's across from angle B. So 15 squared plus 8 squared minus 2 times 15 times 8 times cosine of 150. Type that in. 15 squared plus 8 squared minus 2 times 15 times 8 times cosine of the angle, which is 150 degrees. equals 496.8460. Remember that's c squared. How do I solve for c? Square root. So take the square root of my answer, which is second negative. I get 22.290, which rounds to 22.29 miles. Example number 15. Do I have a right triangle? No, I don't even have an angle, so I don't even know. So no. Do I have an opposite pair? Well, I don't even have an angle at all. So no, I don't have any opposite pairs at all. So I want to use law of cosines. I'm using law of cosines to solve for what? Angle C. So I have to use the one where c squared is by itself because that's the only formula that has angle C in it. The other ones deal with angle A and angle B. Well, what's important to me is which side then is side C? Well, it's the side that's across from angle C, which is 15. Now, A and B could be interchanged. They really don't matter. In this case, I'm going to let 13, which is across from angle A, be side A. I'm going to let 4, which is across from angle B, be side B. So C squared is 15 equals A squared, which is 13 squared, plus B squared. B is 4 squared, minus 2 times A times B. A 13, B is 4 times cosine of C. Now I do need to do this step by step as I work through and hit all my order of operations. Let's start by squaring all the numbers. 225, 169, 4 squared 16, and then multiplying 2 times 13 times 4 to get minus 104. I'm solving for C. I want to get C by itself. I can combine like terms on the same side, which is 169 and 16. Because 104 is being multiplied by cosine, I can't combine that with the other two numbers. So I can only combine 169 and 16 to get 185. My next step, trying to get the cosine of C by itself, so I'm going to leave this term, minus 104 times cosine of C alone, but I want to get rid of the 185. Well, the opposite operation is to subtract 185 from both sides. And I get 40 equals negative 104 times cosine of C. How do I get cosine of C by itself? I'm going to divide by negative 104. That'll cancel out, leaves me just cosine of C. Cosine of C equals cosine of C equals 40 divided by negative 104. Well, how do I undo cosine? The inverse. Cosine inverse. Take cosine inverse of both sides. They'll cancel on the right side. I just have C. C equals what? Cosine inverse of 40 divided by negative 104. So second cosine of 40 divided by negative 104 equals 112.619, which rounds to be 112.62 degrees is the measure of angle C. Example number 16, our last example of the day. I want to find the measure of angle A. Is it a right triangle? No. Do I have an opposite pair? No. Therefore, law of cosines. Using the A squared equals B squared plus C squared minus 2BC times cosine of A. Well, it's the only one that's got angle A in it. I don't want to find angle B or angle C. I want to find angle A. So I have to pick the formula that's got angle A in it. So let's identify our sides. Which side is going to be A then? 10, because it's across from angle A. Well, let's let 7 be B because it's across from angle B. And we'll let 12 represent C because it's across from angle C. Again, A is very important in this case because 10 squared has to go by itself. Now 7 and 12, B and C could be interchanged and flip-flopped if you wanted to. put in my numbers. A is 10, B is 7, C is 12. 2 times 7, 12. So 10 squared equals 7 squared plus 12 squared minus 2 times 7 times 12 times cosine of A. Square all the numbers. Combining like terms. Remember, the only terms I can combine are 49 and 144, which combine to be 193, because 168 here is being multiplied by cosine of A, so it's not a like term. I want to get this term by itself, so I want to get rid of 193. I'm going to subtract it from both sides to do that. 100 minus 193 is negative 93 equals negative 168 times cosine of A. Well, let's get rid of the 168 because I want to get cosine of A by itself first. Divide. The opposite of multiplication is to divide. They'll cancel out on the right. I have cosine of A equals negative 93 divided by negative 168. I'm solving for A. How do I get rid of cosine? What is the opposite of taking cosine? The inverse. Cosine inverse of cosine. They'll cancel each other out. Leaves me with just A. A equals cosine inverse of negative 93 divided by negative 168. Negative 93 divided by negative 168. And I get 56.38. Seven, which rounded to the nearest hundredth, is 56.39 degrees. So that is a wrap up of the review. Again, you should probably only be checking the problems. Hopefully you only checked the problems that you needed help with. You didn't watch the whole video. It is longer, and it's a lot more examples than we normally cover, but there's a lot of different things. So you should be able to do most of them already. Then you can go on to take the quiz. And it's in Schoology. Complete the quiz. You do not need to submit answers for your review on Schoology. So you can go on. It's in the Unit 5 folder. So if you open it up, it's week 6, test number 1, the module 14, solving triangles quiz. That's the quiz you're taking. Read the directions before you do it. If you have any last questions, stop in and see your teacher before you do that. Thank you. Have a good week, and I hope to see you in here. Stop in office hours. We'll see you then, or we'll talk to you in the next video. Thanks. Bye.